Today I will discuss about multiple linear regression. Multiple linear regression. We already discussed about simple linear regression. Now we discuss multiple linear regression. For multiple linear regression, there are one dependent variable and more than one independent variable. In linear regression, simple linear regression, there are one dependent variable and one independent variable. But here, multiple linear regression, there are one dependent variable but more than one independent variable. For example, income depend on age, qualification, and qualification. Then we can write income equal to A plus B into age plus C into qualification plus error term. Error term is common thing of all model. Predicting income based on age and qualification is known as multiple regression. Here independent variable are age and qualification and dependent variable is income. So income depend on more than one independent variable, age and qualification. So this is the multiple linear regression. Let Y denotes the dependent variable that is linearly related to k independent variable. K independent linearly related to k independent variables x1, x2 and xk through the parameters beta 1, beta 2, beta k, and we write y equal to x1 beta 1, x2 beta 2 to xk beta k plus epsilon. This is called multiple linear regression model. where y is the dependent variable and x1 x2 xk is the independent variable, and beta 1 beta 2 beta k are the parameters, k parameters. The parameters beta 1 beta 2 beta k are the regression coefficient coefficients based on beta 1 beta 2 beta k are the regression coefficient associated with x1 x2 xk respectively, and epsilon is the random error. Epsilon is the random error. Multiple linear regression model are two types of multiple linear regression. Multiple linear regression are two types of multiple linear regression model. Multiple linear regression model are two types. One is with intercept model. Another is without intercept model. Without intercept model. Now we discuss about multiple linear regression with intercept. Multiple linear regression with intercept. Let y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus plus beta k xk plus epsilon n tuples of observation. n tuples of observation যদি নেই, মানে n খানা y এর জন্য, n খানা ডেটার জন্য y1 beta naught beta 1 x1 1 beta 2 x1 2 beta k x1 k plus epsilon 1, তারপরটা y2 equal to beta naught plus beta 1 x2 1 beta 2 x2 2 plus beta k x2 k plus epsilon 2. In this way yn equal to beta naught plus beta 1 xn1 plus beta 2 xn2 plus beta k x nk plus epsilon n. In this way we get n tuples of observation y1 y2 yn. Now we can write this n tuples of observation in matrix form. Then we get y1 y2 yn, that equal to 1 1 1 x11 x12 x1k x21 x22 x2k xn1 xn2 xnk. and the multiplication of matrix beta naught, beta 1, beta 2, beta k, adding with epsilon 1, epsilon 2, epsilon n. That imply y equal to x beta plus epsilon. Now we denote the y matrix y1, y2, yn by capital Y, and the matrix this matrix is known, let us consider this matrix capital X, and parameter matrix capital beta, and error matrix epsilon 1, epsilon 2, epsilon n is epsilon. The order of the Y matrix is n cross 1, n rows and 1 column. Order of the X matrix is here n rows but k plus 1 column. So order of X matrix is n cross k plus 1. And order of beta matrix is 0 to k, that is k plus 1 rows and 1 column, k plus 1 cross 1. Here epsilon matrix is n epsilon value, so n cross 1 matrix. This model is known as intercept model, where Y is known as observation matrix. Observation matrix. Beta is known as parameter matrix. Error matrix, epsilon error matrix. Y is known as study variable matrix, study matrix, and X is denoted by observation matrix. Here beta naught is the intercept. For beta naught we get the column 1 1 1 in observation matrix X. Beta naught is the intercept. We already discussed about intercept in linear regression, simple linear regression. Now discuss the model, multiple linear model without intercept. In without intercept model, beta naught is 0. Multiple regression model. Without intercept. Here beta naught equal to 0. Here beta naught equal to 0 and the model is same. Beta naught equal to 0, then y equal to beta 1 x1, beta 2 x2, beta k xk plus epsilon. And the matrix for n tuple, the matrix will be, the model will be y1 beta 1 x11, beta 2 x12, beta k x1k plus epsilon 1. Y2 will be beta 2 x12, 21, beta 1 x21, beta 2 x22, beta k x2k plus epsilon 2. In that way yn equal to beta 1 xn1, beta 2 xn2, beta k xnk plus epsilon n. In that way we get the n-tuple matrix. The n-tuple matrix will be y1, y2, yn. It is the study variable matrix. And the observation matrix is x11, x12, x1k, x21, x22, x2k, xn1, xn2, xnk. And the parameter matrix is beta1, beta2, beta k. And error term matrix is epsilon 1, epsilon 2, epsilon n. And the matrix denoted by capital letter study variable matrix capital Y, observation matrix capital X, parameter matrix beta, and epsilon matrix. The order will be n cross 1, n cross k, k cross 1, n cross 1. Now we discuss about model assumption of multiple linear regression model. For multiple linear regression model, we assume some assumption. Model assumption. We consider the model is without intercept. We discuss about without intercept model here. For multiple linear regression model without intercept. The model will be y equal to x beta plus epsilon. This is the without intercept model. So order of the matrix y is n cross 1, order of matrix capital X is n cross k, order of matrix beta is k cross 1, and epsilon is n cross 1. The first assumption is epsilon follows IID normal 0, sigma square in. That's mean epsilon follows identically, and IID means identically distributed. That is normal distribution follows korche normal distribution with mean 0 and variance sigma square. Second assumption is expectation of epsilon equal to 0 and variance of epsilon equal to expectation of epsilon into epsilon dash equal to sigma square in. This assumption coming from first assumption, the mean and variance of epsilon normal distribution follows epsilon, the mean and variance of epsilon. Third is rank. Rank of x is k. Number 4, x is a non-stochastic matrix, and epsilon follows IID. IID means identically, independently distributed. Identically and independently distributed. Next we estimate the parameter. Parameter estimation. How to estimate the parameter? Parameter means beta. X equal to y equal to x beta plus epsilon is the our multiple linear regression model. From here we get epsilon equal to y minus x beta. Now we write s beta equal to I running from 1 to n epsilon I square. This is the sum square error. This is also denoted by epsilon dash into epsilon. Why epsilon dash into epsilon? Epsilon dash is the transpose matrix of epsilon and epsilon is the error matrix. So after multiplication we get summation epsilon I square. How it's possible? Epsilon dash into epsilon. Epsilon dash means epsilon 1, epsilon 2, epsilon n, and epsilon means epsilon 1, epsilon 2, epsilon n. After multiplication we get epsilon 1 square plus epsilon 2 square dot epsilon n square. Matrix multiplication, that is also known as I running from 1 to n epsilon I square. So we can write epsilon I square summation I running from 1 to n epsilon I square equal to epsilon dash into epsilon. The value of epsilon is y minus x beta. That's transpose into y minus x beta. Transposing this we get, after transposing the y minus x beta we get y dash minus beta dash x dash. Now multiply y dash minus y dash into x beta minus beta dash x dash y plus beta dash x dash x beta. The quantity is same. This is the same. এটা ট্রান্সপোজ করলে এটা পাবো, যে কোনো একটা ট্রান্সপোজ করলে আর একটা পাবো. সো দ্য ভ্যালু অফ দিস সেম. So we adding these values we get 2 of beta transpose x dash y plus beta dash x dash x beta. Now we find the normal equation using least square method. Now we apply least square method to find normal equation. So derivative করব s beta কে with respect to beta, that also equal to 0. This is called normal equation. Now we differentiate with respect to beta. S beta with respect to beta. The first term is y dash y, যেটা ডিপেন্ড করছে না বিটার ওপর, সো ডেরিভেটিভ করলে হয়ে যাবে 0. তারপরে বিটার ডেরিভেটিভ করলে হবে 2x ড্যাশ ওয়াই প্লাস এখানে বিটা ড্যাশ ইন্টু বিটা আছে মানে বিটা স্কোয়ার. বিটা স্কোয়ারের ডেরিভেটিভ করলে হবে 2 বিটা, তাহলে আসবে 2x ড্যাশ x বিটা ইকুয়াল টু 0. আফটার ডেরিভেটিভ উই গেট দিস. Now we can write 2x dash x beta equal to 2x dash y. Cancelling x2 and 2 both side we get beta x dash x beta equal to x dash y. Now here beta equal to x dash x inverse x dash y. This is known as parametric value, estimated value of beta. This is the capping value, that is y hat equal to x beta hat. The estimated value of y is y hat equal to x beta hat, where beta hat equal to x dash x inverse x dash y. From here we find error. Error is the difference between actual value and estimated value. Actual value is the y or estimated value is the y hat. So y minus x beta hat is the error term. Now we find sum square error. sum square error, how to find? Sum of error quantity in terms of I running from 1 to n, that is e dashed e. E means, sorry, এখানে y হবে, y minus x dash beta. So e means y minus x dash beta, x beta hat, that transpose into y minus x beta hat. So we get, after transposing beta hat dash x dash y minus x beta hat, now we multiply y dash y minus y dash x beta hat minus beta hat dash x dash y plus beta hat dash x beta hat. So these two quantity are same. Now we adding y dash y minus 2 beta hat dash x dash y plus the value of x dash x beta is x dash x beta is x dash y, putting the value of x dash x beta, that is x dash y. This is the same term. Now we subtracting, get y dash y minus beta hat dash x dash y. This is known as sum square total sum square. This is known as sum square regression. So we get e dashed e equal to y dashed y minus beta hat dash x dash y. That imply y dashed y equal to beta hat dash x dash y plus e dashed e. That is total sum square total. That equal to sum square regression plus sum square error. This is the sum square total, sum square regression, sum square error. Now we also write the degrees of freedom. Degrees of freedom is the subtraction, the restriction from their values. Here n tuple of observation used, so degrees of freedom of SS total, SST sum square total is n minus 1. 1 is the restriction, and k terms of regression used, k parameter used, so k minus 1 is the degrees of freedom sum square regression, and their subtraction, their difference is the n minus k is the degrees of freedom of error term. So now we write the ANOVA table for multiple regression. ANOVA table. ANOVA table means analysis of variance table, where we summarize the sum square total, sum square regression, etc. Source of variation. First column of ANOVA table is source of variation. Then sum square, sum of square, then degrees of freedom, then mean square, then test statistic. Here some source of variation, two source of variation, one is regression, another is error. Their sum will be total. From regression we get sum square regression, from total we get sum square error, and from error we get sum square error, and from total we get sum square total. Their respective degrees of freedom n minus 1, k minus 1, n minus k. and their mean square is mean square regression, that is sum square regression by their degrees of freedom k minus 1, and sum square regression SS and mean square error regression. From sum square error we get mean square error. Mean square error equal to sum square error by degrees of freedom. Here also get mean square total, sum square total by degrees of freedom. Here test statistic will be f test statistics, f distribution, that will be mean square regression by mean square error. Mean square regression by mean square error follows f distribution with degrees of freedom, mean square regression, that is k minus 1, and mean square error, that is n minus k. Now discuss about coefficient of determination. We already know the coefficient of determination with respect to simple linear regression model. Now we discuss the coefficient of determination for multiple regression model. Coefficient of determination and adjusted R square. Coefficient of determination, here discuss coefficient of determination denoted by R square. Let R be the multiple correlation coefficient between y and x1, x2, xk, then square of multiple correlation coefficient R square is called the coefficient of determination. The value of R square, commonly describes that how well the sample regression line fits to the observed data. This is also treated as a measure of goodness of fit. Measure of goodness of fit of the model. And mathematically it is denoted by R square, that equal to 1 minus E dashed E by Y dashed Y. E dashed E means sum square error and Y dash Y means sum square total. After LCM we get sum square total minus sum square error by sum square total. Sum square total minus sum square error is sum square regression by sum square total. Range R square এর রেঞ্জ হলো 0 to 1. R square equal to 0 indicates the poorest fit of the model. R square equal to 1 indicates the best fit of the model. Model is best fit. R square equal to 0.95 indicates that 95% of the variation in Y is explained by R square. The model is 95% good. The model is 95% good. R square belong to 0 to 1 indicates the adequacy of fitted model. Now discuss about adjusted R square. If more explanatory variables are added to the model, then R square increase. Then use adjusted R square. Adjusted R square is the R square same process by adjusting their degrees of freedom. 1 minus SSE by SST is the R square. If we divide SSE by n minus k and SST by n minus 1, we get adjusted R square. This is 1 minus R square. The limitation of adjusted R square is that it can be negative also. Adjusted R square can be negative, but R square always positive. For example, k equal to 3, n equal to 10 and R square equal to 0.16. Then adjusted R square will be one minus n minus 1 by n minus k, that is 9 by 7 into R square, 1 minus R square. So after calculating, that will be minus 0.25, that is negative. So adjusted R square will be negative, but R square always positive. That's the difference between adjusted R square and R square. Now we discuss the test, how to test the multiple linear regression. Obviously here use hypothesis test. H naught is beta 1, beta 2, beta k, all are zeros, and alternative is at least one beta I not equal to 0 for all I 1 to k. Here test statistics is the F, mean square regression by mean square error. We can write mean square regression, sum square regression by k minus 1, and mean square error we can write sum square error by n minus k, that is n minus k by k minus 1 SSR by SSE. That also can write n minus k by k minus 1 SSR can be written as same, but SSE we can write SST minus SSR, dividing denominator and numerator by SST. So we get SSR by SST, SSR by SST by SST minus SSR by SST. N minus k by k minus 1 SSR by SST means R square, and 1 minus SSR by SST. So we get n minus k by k minus 1 R square by 1 minus R square. This is the important relation between state statistics and R square, coefficient of determination. Model assumption for multiple linear regression. Number 1, the relationship between the study variable and explanatory variable is linear. Number 2, the error term has zero mean. Number 3, the error term has constant variance. That's called homoscedasticity. Homoscedasticity. Number 4, the errors are normally distributed. The errors are normally distributed. Number 5, observations are independent. Observations are independent. Number 6, the errors are uncorrelated. That is no auto correlation. Number 7, no multicollinearity. That is, independent variable are not highly correlated. Independent variables are not highly correlated. This is called no multicollinearity. If highly correlated, then called multicollinearity exists. Now we solve a problem on multiple linear regression.